Let's talk about SF objects, which are the simple feature objects created by the SF package. And an SF object is really a data frame that also has an included simple feature geometry list column. That sounds very complicated, but basically it's a column of geometry objects. So essentially what that means is that you can work with SF objects very similarly to how you would work with a data.frame object, though it may have some slightly different default behaviors because it's not only a data.frame, but it's also an SF object. And so there may be some default behaviors for the SF object that are a bit different. So just to be clear, the geometry list column contains the geometry object for each observation. The other columns of the SF object contain the attributes associated with each of the geometry objects. And similarly, each row of the SF object is a simple feature. Alternatively, you could say that each observation is a simple feature. And so we have this data frame, and it's just really just a simple feature object, an SF object in R, is really just a special kind of data frame in R. In practice, SF objects are usually created by reading in a shapefile or something like that. However, particularly for point observations, it's possible that you may need to create an SF object manually. You may not have a shapefile for point objects. So in what follows, we're going to create SF objects for point geometry types and polygon geometry types. And then as you'll see, we'll actually try to create a third by combining those two. And we can actually use the same previously discussed functions, for example, st_point and st_polygon, to create the geometry objects. And then we're going to use the st_sfc function to create a geometry list column. And then the st_sf function is used to create a data frame of attributes with the geometry list column. In other words, this is the function used to create the SF object. So in this code below, what I'm doing here is I'm creating a point here at location 0, 0, another point at point 0, 1, another point at location 1, 1. And what I'm going to do here is now I'm going to take each of these points, put them in a list, and then use the st_sfc function to create a geometry list column. And if you use the is.list function to determine whether glc1 here is a list, it returns true. So we do know that this is in fact a list. And if we look at the class of glc1, we see that it is of class sfc because it is a simple feature geometry list column. And specifically, it's sfc_point. And so all the points in this column are of point type. So we want to keep working toward creating this simple feature or SF object. So I'm going to create a data frame. And since we are talking about point data, it makes sense to imagine measurements that can be measured at a specific location. So for example, we could think about measuring the temperature at each one of those locations or rainfall. So I've just created some vectors here of length 3 for temperature and rainfall, toss them into this data.frame, store that as df1, and then to create my SF object, I use the st_sf function. I give it the data frame first, and then I specify the geometry list column, which is glc1. I given it the name geometry because that's usually the default name that the SF package will give if you import a shapefile, but it could actually be something else if you wanted it to be. And I've created this SF object sf1. Having created my first SF object here, I might want to know what class it has, and you can see from running the class function on the object that it is an SF object or has class SF, as well as data.frame. And so really the SF class is an extension of data.frame. And as I previously mentioned, this means that we can work with SF objects very similarly to how we can with data.frame objects, which is really, really convenient. There is a built-in plot function for SF objects, and so I can plot SF1. I'm going to snag the temperature variable. I use PCH equals 20 to have solid dots instead of open circles. They're a little easier to see. And I'm going to add axes, which are not added by default. And I get the plot right here. So we have the nice little color scale to see the different levels of our points here, what the values are, and we have a very simple basic plot. Now I'm going to do something similar, but for polygon objects. And essentially what this is going to do is this is going to create a 1 by 1 square polygon that has its lower left corner at 0, 0. I have this matrix of points here. Each row is a different point. I put that in a list and then use the st_polygon function to create a polygon. And then I'm going to create a second polygon based on another ring outer 2, which is just the outer one ring shifted 1 unit to the right. So if you look here, I've taken all of these x coordinates. These would be the x coordinates in this matrix. I've added 1 to each one of them so that I get a second polygon square that's going to be directly to the right of the first square. I once again put that in a list. I use the st_polygon function to create a second polygon. And then to create a geometry list column, I'm going to put the polygon objects in a list and then use the st_sfc function to create my second geometry list column. If I check the class of the second geometry list column, I see that it's of class sfc because it's a column of a simple feature object, a geometry list column. And the other class is sfc_polygon because each element of that list is a polygon object. I can use the stsf function now to create an sf object. Notice now that instead of adding or providing a data frame, I'm literally going to provide a single column, cases, that has numbers for each one of the elements of my geometry list column since it's only of length 2. I also provide the geometry list column as the second attribute or the second column of the SF object here. And so this creates SF2, my second SF object. If I look at the class of SF, it's actually the same as the first SF object I created. It's just a data.frame that's been extended to an SF object. I can now use the plot function to plot SF2, and I get this right here. I said we had 2 polygons, and this color bar right here is supposed to indicate the values associated with each one of these polygons. You may wonder, what happens if I actually combine different types of geometries into a geometry list column? So that's what we're going to explore here in this last example. So I'm going to use the st_fc function to create a geometry list column from the geometry objects point 1, point 2, point 3, PL1, and PL2. These are all points. These are both polygons. And if I look at the class of GLC3, the geometry list column I created, we can see that it's still an SFC, but now it's SFC_geometry because it doesn't have a single type like before. So it just generically says that each element is some type of geometry in the geometry list column. And I can, in fact, or surprisingly, I think to me, you actually can create an SF object for this, or maybe this part is not really surprising, but what's surprising is that you can create this and try to plot it. It doesn't make a whole lot of sense, as you'll see, but it works philosophically, I guess. And so what I'm going to do here is I'm going to take this geometry list column. I'm going to randomly sample 5 values from a standard normal distribution, add that as an attribute to each element of my geometry list column. I create SF3 here. I look at the class. It's the same class as before. It's just SF, which extends data.frame. And now I'm going to try to plot SF3. I've changed the color palette here to use topo.colors. I used PCH equal to 20 because I wanted those solid circles instead of the open circles like before. And what's going on here is, you can actually see the points. You can see the point here, and the point. It's really hard to see because it's yellow, but there's actually a point here. And then we have different colors for these 2 polygons. And what's kind of bizarre about this is that we don't have equidistant class breaks or breaks in our different levels of our color scale here. I actually don't know why that's the case. I think maybe it's trying to distinguish more points with more colors or something like that. If we wanted to have this have equidistant breaks with equidistant colors here in our color scale, then we can manually specify the breaks argument of the plot function, which I've done here. And so I've taken essentially the smallest value of the attribute 1 column of SF3, the maximum value, and I have 12 different breaks, which I think should match up with 11 different colors. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 colors. We actually are not going to use them all since we only have 5 observations. And we can see the colors here. We see the colors in our point objects. And you can construct a plot of this complicated SF object. It wouldn't be very useful. I will say this would not be a good practice. This was really done for philosophical purposes. If you had different geometry types, so for example, you had polygons and then you had points, it would be much better, instead of including them all in a single geometry list column, to create a plot of one of those types of variables, and then you can actually create a second plot and add it on top of the original plot by adding an argument called add. You would just say add equals true, and it would plot the next geometry, or the next set of simple features on the original plot, perhaps with the same color scale if you wanted to do that. And that would be a much better way to go, in my opinion. We're not going to talk about that. It's a little more complicated than we want to get. But there's a lot you can do with the simple feature objects that we're creating.